Good morning, student. Today we will see another method of solving the circuit and finding the current in various branches of the circuit. Okay, that method is anti-symmetry circuit, student. Okay, now suppose student, we have this kind of circuit. Say this is say 2 ohm, this is 3 ohm. One resistor like this is here. Now this is 3 ohm and this is 2 ohm. This is say any value 5. And here, student, one battery is connected. I am taking battery of 10 volt, student. Okay, I have to find out various current in the various resistors of this circuit. Now, student, what anti-symmetry means? See, the situation left of this is 2 ohm, this is 3 ohm. Here 3 ohm is there, here 2 ohm is there. So suppose the current through this resistor is I1 and current through this resistor is I2. Then, student, for this 2 ohm also current will be I1 only. This is known as anti-symmetry method. From here, student, 3 ohm, 3 ohm. If this current is I2, here also current I2 will be there. If you can solve it, if you check it by solving by any method, you will get this value. Okay, you can check it, student. You will get the same current. So I am using this method, anti-symmetry method. This is known as, it is 2 3, it is 3 2. So if the current is here is I1, here also current is I1. If current through this is I2, here also current will be I2, student. Okay. Now, student, now, student, it is very easy to find out this current. Current through this resistor. This I am naming it as, student, I3. Okay, student. Now I will start first with nodal analysis. This point I am taking it as 0. So this will also be 0. This is 10, student. This is 10. This is directly I cannot find out voltage there. So I will write it here V1. Here also I cannot find it directly. I will write it V2. Okay, student, this is the first method, nodal analysis. A first step, I should say. Now, student, you see one more thing. In this part, current is I1 and resistance is 2 ohm. Here also current is I1, resistance is 2 ohm. Hence, the potential difference across this must be same as this. This method will be utilizing. So, V2 is not required here, student. See, here the potential difference is 10 minus V1. So, here also the potential difference should be 10 minus V1. So, this point instead of V2, now I can write it, student, 10 minus V1. You check it. The potential difference is same, 10 minus V1. It is 0 here. Now, student, I will apply junction rule at here. Now, see only one variable, one equation. I will apply junction rule here, student. See, I1 towards the junction, I3 away from the junction, I2 away from the junction. So, junction rule is, student, I1 will be equal to I2 plus I3. Now, how much is I1, student? V upon R. 10 minus V1 upon 2. I2, student. V1 minus 0 upon 3. This is V1, student, okay? Plus I3. I3, student. Here, student, V1 minus V2, and already I have taken it 10 minus V1. I have explained you the method. So here the potential difference is, student, V1 minus 10 minus V1 upon 5. Okay, student, what I have done, see, I1 is equal to I2 plus I3. This is I3, student. Now I have to solve this equation. Okay, let's solve it. This part, student, I am writing it here again. 10 minus V1 upon 2 is equal to V1 upon 3 plus part I am writing here, student. Okay, V1 minus 10 plus V1. V1 minus 10 plus V1 upon, student, 5. Now I am writing it here, student. The same step, 10 minus V1 by 2 is equal to V1 by 3 plus student twice V1 minus 10 upon 5. Now student, you have to simplify it. Ten minus V1 by 2 minus V1 by 3 minus 2V1 plus 10 upon 5. Here student, I have opened the bracket, okay? So, and this I have taken this side. So this is minus, this will become minus, and this will become plus. Okay student? So this I can write it in a more easier way like this. 2V1 upon 5 plus 10 upon 5, student, is 2. This 10 I am writing, this is this voltage, student, okay? Now student, if you this is equal to 0, student, okay? Now let's take the LCM. 10, 2 5 are 10, 50 minus 5V1. No, sorry student, 10 will not be the LCM. 30 student, 30. 2 15 are 30, 150, 15 into 10, 150 minus 15V1. 3 10 are 30, 10V1. 5 6 are 30, 12V1 plus 60 is equal to 0, student. Now student, you see, minus 15V1 minus 10V1 minus 25 minus 12 minus 37V1. 150 plus 60 is how much, student? 210. I am writing is equal to minus 210. This will become 0. Now I got the value of V1, student. Now if I get the value of V1, you can see, you can find any current. I1 substitute here, I2 substitute here, I3 substitute here. You get all the current, student. You see, all the current, you already got it. So this is, student, how the anti-symmetry method can be utilized to solve this kind of circuit, student. Now one more thing, student. Suppose in this circuit it is asked to find out this point is A, this point is B. Okay, it is asked to find out equivalent resistance between A and B. Equivalent resistance between A and B. So student, by series parallel method you cannot find it. So what you can do, student, is see. In this circuit, student, the net current is how much, you see? I1 plus I2. This is the net current. Okay. So total current in this circuit is I1 plus I2. Suppose I replace it by a single resistor and I connect this battery, and the current is same, I1 plus I2. Then the R of this circuit will be given by, student, E upon I1 plus I2. E is this 10, and I1 plus I2 I will get just now this by this method what we have solved. So got it, student, how you can find R equivalent of this circuit? You find out total current, okay, and then you do V upon I, that is equivalent R. So student, this is a very easy method to find out equivalent resistance. You can easily find out. Now let's solve, student, another question. To make the concept more easier, let's solve a complicated circuit, student. Say the circuit is of this kind, student. This is A and B. Okay. Just I am taking any values, student. Again the same 2 ohm, 3 ohm, 3 ohm, 2 ohm. This is I am taking 4 ohm, 4 ohm. This is I am taking 5 ohm, 5 ohm. And I have to find out current in various branches. Okay, student. Now, suppose in this resistor current is I1, this current is I2, and this current is I3. Now you see, student, symmetrical rule. I1 2 ohm, this is 2 ohm. The current anti-symmetry rule, okay? Here the current will be I1. This is I3, here current will be I3. You can, student, solve it and check it. The current will be same. I am applying directly that rule, okay? So in competitive exam or in exam directly you can apply. So that time will be saved. This is I2, so this is also I2. Okay, student. Now, again, nodal analysis. This is 10. This is 0, this is 0, this is 10, this is 10. Again, student, what I will do is, here it is unknown volt, I will write it V1. V1 I will write it. Okay. Now, student, you see at this junction. Suppose, student, at this junction the voltage is X. And I will apply junction rule at this junction. See, I2, this is also I2, both are same. Both currents are same. So here I2 will be how much? 10 minus X upon 5. And here I2 is how much? This X, X minus 0 upon 5. If you solve it, student, you will get X is equal to 5 volt. So now, student, I got the potential here 5 volt. Okay, student. Now, student, I will apply junction rule here. Suppose current through this resistor is I4. Here apply junction rule. See, student, I1 towards the junction, I4 and I3 out of the junction. So I1 is equal to I3 plus I4. How much is I1, student? Again, 10 minus V1 by 2. How much is I3, student? This is I3, student. V1 minus 0 by 3. I4 is this part, student. Just now I got it 5. V1 minus 5 by 4. Student, and you solve it, you get V1. Once you get V1, you get all other current. You see, every current you got it. Also, student, you can find out equivalent resistance between these two. How will you find out? See the total current. I1, I2, I3. This is the total current. Okay. This is V. V upon I is R. So by this method, two questions are solved simultaneously, student. One, current in various branches, and second, the equivalent resistance also you can find out. Okay. So today, student, we have discussed this anti-symmetry rule. By seeing the anti-symmetry method, you can find out the current, you can equate it and you can solve it. So student, today you have to solve some more problem related to this. Next, we will continue in the next class. Thank you, student.